Hello, math students. Welcome to our module on statistics. And the title of this lesson, Lesson 1, is Understanding Distributions. The goal for our lesson today we will learn how to identify different types of data and how to use them. The question that I want you to be thinking about during the lesson is, what are the two types of data that we have in mathematics? So I do have to let you know that this bit of notes is very, very heavy in vocabulary, lots of words, lots of notes, and if you do not want to write down everything, you do not have to. However, I do need you to pay very close attention because there are key vocabulary words and pieces of information that you have to understand in order to make sense of this next module on statistics. So we're going to talk about some things to remember, and hopefully it is things to remember for you that you've heard about it before, and if not, then it's brand new information. If it is something you've heard of before, then we can have the conversation about it. So, things to remember. Statistics is a type of math that allows people to understand things based on data. There are two types of questions used to identify data. They are called statistical questions and non-statistical questions. Okay, a statistical question is a question that obtains data of a set of given information. All right, so I want to underline that because your job in this lesson and according to this standard is that you have to be able to tell the difference between the two types of questions. And so, again, a statistical question is a question that obtains data of a set given information. A non-statistical question is a question that does not provide information about the data. It may ask a question and you will get an answer, but it doesn't directly relate to the data that you're looking for. You have to collect data to answer the question. If you do not collect data, then the question is not statistical. So, for example, if I ask you the question, how is your day? How is your day is a non-statistical question because it doesn't give me any data information. It's just an answer to a question. How is your day? My day is good. Okay, so that is not any actual mathematical data that I can use to collect, to look at trends or to look at reasons why things happen that they do. It's just a question asking you how your day is. So what your job is in this standard is to be able to tell the difference between a statistical question and a non-statistical question. So here is an example of the different types of questions. Jerome, a sixth grader in Roosevelt Middle School, is a huge baseball fan. He loves to collect baseball cards. He has cards of current players and of players from past baseball seasons. With his teacher's permission, Jerome brought his baseball card collection to school. Each card has a picture of a current or past Major League Baseball player along with information about the player. When he placed his cards out for the other students to see, they asked Jerome all sorts of questions about his cards. Some of the kids asked, "What is Jerome's favorite card? What is the typical cost of a card in Jerome's baseball collection? For example, what is the average cost of the card? Are more of Jerome's cards for current players or for past players? And which card is the newest card to Jerome's collection?" So those are the questions that all of the kids wanted to ask Jerome about his cards. So what our job as these statisticians is to be able to understand which one of those out of all those questions are statistical questions and which ones are non-statistical questions. In the example above, which questions are statistical? The data from statistical questions is organized in two different categories. The categories are numerical data and categorical data. Numerical data is data that has numbers. Categorical data is data that uses words. Which is which? So basically what we have to decide is, of each of the questions up above, are they statistical or not statistical? And then once we've decided that they are statistical, we have to decide, is the data that is collected using numbers or is the data that's being collected using words? So let's go back up to the questions and see what we can figure out. What is Jerome's favorite card? So if we're looking at that and we say, what is Jerome's favorite card? Do we have an answer that answers in numbers? Do we have an answer that answers in words and clearly gives us some data? So I would say for this question right here, what is Jerome's favorite card? I would say that's a non-statistical question. And the reason why I would say it's a non-statistical question is because it doesn't provide information about data. Okay? What is the typical cost of a card in Jerome's collection? For example, what is the average cost of a card? I would say that that is a statistical question because if you're looking for typical cost or average cost, that means you're collecting the price of different cards, and so that involves numerical data. When you go to Walmart and you see that the card costs this much, if you go on Amazon, you see that the card costs this much, if you go to baseball card shop, that the card costs this much, that's all collecting data, and you have numerical evidence of what the cost of the card would be. So that I would say is a statistical question. So I'm going to say on this one would be non-statistical, whereas I would say this one is considered statistical. Are more of Jerome's cards for current players or for past players? Then I would say that what you're looking for is you're looking for current players versus past players, which that could be considered data. You're looking through the cards and you're saying, oh, current player, past player, current player, past player, current player, past player. And by the time you go through all of his cards, you have two different piles which has data in it. So I would say that the third question is a statistical question because you're collecting data about the types of players that they are. Which card is the newest card in Jerome's collection? I would say that that one itself is probably a non-statistical question. And the reason why this is a non-statistical question is because there's only one card. And that happens to be the one that he acquired the most recently. So there's no data to collect. So I hope that by looking through those 4 examples of questions, it was a way for you to be able to see this one's non-statistical, this one is because you're collecting data, this one is because you're collecting data, this one is non-statistical because there's no data to collect. Okay, so now that we have figured out which ones are statistical, now we have to decide what type of statistical they are. So we're not going to look at the N's anymore because those are non-statistical. We're going to focus only on the S questions. And remember the 2 categories that we have is we have numerical data and we have categorical data. Numerical data means that it's data that is numbers. Categorical data is data that has words. Okay, so reading this one. What is the typical cost of a card in Jerome's collection? For example, what is the average cost? Well, again, because we talked about that question a little bit, this involves numbers. So we would say it's a statistical question using numerical data, okay? And because we're involving numbers. Are more of Jerome's cards current players or past players? I would definitely say this is categorical because you're looking for current players versus past players. So those are words. Those don't have anything to do with numbers, but they do break up the cards into 2 different categories. So this would be categorical data. Numerical data because of the numbers, categorical data because of the 2 types or the 2 categories that we're breaking the data into. Okay? So that one's kind of helpful, figuring out the 2 types of statistical questions that we have. So again, your goal in this standard is that you have to be able first to identify whether the question is collecting data, statistical or non-statistical, and then once you know that it's a statistical question, you have to be able to say what kind of data are we looking for? Are we looking for numerical data or are we looking for categorical data? All right, so now to help us along with this, the next part is you conduct a survey. And surveys happen all the time, kiddos. Surveys are where you ask a population a question and you're asking them to answer the question, and then what they do with that information from your answer is they put it into piles of data. So you conduct a survey about the following things. decide what type of data each survey is obtaining. So if you were doing a survey about people's eye color, what kind of data would you be receiving? Would you be receiving numerical data, or would you be receiving categorical data? And for eye color, I'm going to say that this is categorical. Why? Because you're talking about colors. So this one would be considered categorical. Okay, I hope you're able to see that. Okay, so now let's look at the next one on the list. What about if we were asking a survey about people's favorite TV shows? Again, I would say that one is categorical. And the reason why is because you're making a list of television shows. Television shows are typically not called numbers. They're called different names, and so those are considered categoricals, the different types of TV shows. All right, the amount of snow Flagstaff has received this school year. So on that one, I would definitely say that it's numerical because you're talking about inches or feet of snow, which are numbers. So this would be numerical data because you're actually writing down numbers of data, okay? The high temperatures of the month of February, again, I'm going to say numerical because you're using numbers to help you collect the data. 83 degrees, 42 degrees, 57 degrees, 12 degrees. Those are numbers, okay? And that's what temperatures are based off, is numerical data. All right, so we're doing a lot of information very, very quickly, as you can see. Statistical versus non-statistical, the two types, categorical or numerical. And so what we need to do now that we know the different types of data is we have to figure out a way to organize them. And so we're going to talk about now ways to organize data. Once you have your data, you need a way to show it off. There are three types of displays that we will look at. The three types of displays are the dot plot. Okay, so dot plot might look something like this. I'll put a star. Okay, a frequency table is the second one. Okay, and this is a frequency table right here. And then we're also looking for a histogram. Okay, that's the third type. And so our histogram is right here. So we have three different ways to organize our data. The first one that we did was the dot plot. The dot plot is a graph that uses a horizontal line and dots to display the data. So we have one line across the bottom, and typically that would be like your x-axis on a graph, right? So we have that one line, and then you put your data underneath your x-axis. So we have rabbit, dog, cat, horse, bird, mouse, fish, or other types of animals. And this survey was pets in our class. And so the dot plot organizes that. There were 2 rabbits, there were 4 dogs, there were 6 cats, there was 1 horse, there were 3 birds, no mice, 2 fish, and something that doesn't fit into those names that is still considered a pet goes under the other. So this is called a dot plot. What you need to know about a dot plot is the line is horizontal, the data name goes under the line, and then the dots represent the numbers of the amount of data that's represented by each type. So that's a dot plot. The next type that we have is a frequency table. A frequency table is a table that shows the number of responses for each data point. So if we have types of pets, then we have in this frequency table 3 columns, and what the 3 columns represent is the data itself that you're collecting. The tally represents how many times someone voted for that or said that that was theirs, and then the frequency is the numerical value that is represented by the tally marks. So a lot of times on a frequency table you may not have this middle column because they will just take that middle column out and just put this and this. But I like the way this frequency table is built because it shows you how we obtained the frequency or how often that animal came up. So the type of pet, we have dog, cat, goldfish, budgie, I don't know what that is, a hamster, a lizard, a snake, or a rabbit. Okay, so those are all of the different types of pets that people listed in the survey about types of pets they have. And then we went and asked these people in the survey, Well, the tallies represent the number of people who had a dog. So if you're a person that had a dog, we would put your tally here. So after we collected all of our data, we tallied them up, and there were 12 people that had dogs. There were 7 people who had cats. There were 6 people who had goldfish. There were 3 people who had a budgie, whatever that is, sorry. There were 2 people that had hamsters, 1 person who had a lizard, 1 person who had a snake, and 3 people that had a rabbit. So the frequency table lists what the data is and the number of times it was actually voted for or said that they had. Okay, so the frequency table is really cool because it kind of shows all of your information in one concise table. And the tallies are awesome because we just go and put the tally marks until we've collected all the data, and then we just write the number, which is the frequency. Okay, the last type that we use to organize our data is called a histogram. A histogram is a graph that uses horizontal and vertical axes to display data placed on intervals. So we have the x-axis, just like on our coordinate plane, and we have the y-axis, just like on our coordinate plane. But the thing that is very, very important that you understand about a histogram is that a histogram uses bars to represent the data, not dots, not lines. It uses bars. The other thing that is super, super, super crucial about a histogram is that your bars have to be touching because there is no overlapping in your numbers that you have on a histogram. So let me talk about that. Along the x-axis, what you have is you have number ranges in intervals. And so what you do is you make these intervals evenly spaced along the x-axis, and then you color in the bar that's represented by those intervals. So if you read this graph, that's why labeling is also really, really important. But if you read this graph, we can totally understand what this graph is saying. It says M&M's as favorite candy. Okay, so they did a survey where they walked around and they asked people, what is your favorite candy? And then they decided, okay, we have a lot of people who said M&M. So then they wanted to break down that information even more because they wanted to find out, does it matter how old you are to determine if you love M&Ms as your favorite candy? And so what they're actually using as their intervals is they're saying age groups and years will be represented by the different people surveyed. So they surveyed people who was 0 years all the way up to 30 years old. And because they have to represent that data on the graph, they decided to break their graph into intervals of 5. So if you count it, you will see that we have those intervals. So let's see if we actually have 5 or if we actually have 6. So right here we have 0, 1, 2, 3, 4, 5. So that's actually 6 in that interval. Let's count this one. 6, 7, 8, 9, 10. So that's 5 in that interval. 11, 12, 13, 14, 15. That's 5 in that interval. Then this one would be 16, 17, 18, 19, 20 in that interval, which is 5. Okay, 21, 22, 23, 24, 25. That's 5 in that interval. And then 26, 27, 28, 29, 30. That's 5 in that interval. So all of the intervals are actually counting in groups of 5. So that's why we have 0 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30. This one, if you counted the 0, it actually had 6, but 0, again, has to be reminded, it's just a placeholder. Okay, so there actually might be children that are 0 years old that eat M&Ms, but I doubt it very seriously because moms and dads of 0-year-old children are not supposed to feed them chocolate when they're 0. So that probably really was not included in the data, but maybe. But anyways, we always include 0 in that first beginning section of your intervals, and then your intervals always have to be evenly spaced. So 5, 5, 5, 5, 5, and 5, but you don't include the 0 in there, considered as the 5. So those are the intervals. Now, to go back and talk about what I said about there can't be any space in between your bars, it's because your intervals go right up to the next number. So as you see, this one represents 0, 1, 2, 3, 4, 5. We don't have a 5.5. We just go from 5, and then our next number is 6. So this bar is touching this bar because 6 starts right there, and it goes 6, 7, 8, 9, 10. and then 11 is in the next one, so they have to touch 11, 12, 13, 14, 15, and then 16 comes right after 15, so they have to touch 16, 17, 18, 19, 20, and then this one, the next one is 21, so 21, 22, 23, 24, 25, they're touching, and then the next one is 26, 27, 28, 29, 30. So the intervals on a histogram, and boys and girls, the reason why I'm trying to stress this is if you see a graph where there's gaps in between your bars, you know it is not a histogram. What makes a graph a histogram is that the bars are touching, okay? They are touching because the intervals touch right up next to each other, and then the next interval starts. And your intervals have to be evenly spaced, okay? Then how you would read it, according to this graph, says the number of people in each one of those age groups. So what we can read from this graph is that from the ages of 0 to 5 who have a favorite candy of M&Ms, it's less than 10 people. In the ages of 6 to 10 years old, we see that it's almost very close to 30 people who love M&Ms, so maybe 27. Then you look at this one, 11-year-olds to 15-year-olds, close to 50 kids love that as your favorite. And then 16 through 20, it's above 50 who that is their favorite candy. 21 years old to 25 years old, it's a little under 40. And then 26-year-old to 30-year-olds, it's almost even with 6 to 10-year-olds, so somewhere around 26, 27. That's their favorite candy. So that's how you read a histogram, okay? So remember, a histogram is a graph that uses the horizontal and vertical axes to display data placed in intervals, evenly spaced intervals that are always touching, okay? So those are the three ways to organize our data. And boys and girls, I know this is a lot of information, but welcome to statistics. Okay, we have one more page to go through, and then we'll be finished. Okay, there are some important things to know and remember about histograms. The shape of histograms, okay? That is a very, very important thing that you have to be aware of, okay? And we have shapes that describe the histogram, and their shape is very important because it tells you what the data was or what the data means, what it looks like. The shape of a histogram tells you the information about the data. There are different shapes. There are symmetrical shapes or skewed shapes, okay? Those are the two types, all right? And the two types are very important because if the data is symmetrical in shape on a histogram, then it means that you could fold your histogram in half down the middle, and the data that's collected on this side of your histogram will be equally the same as the data collected on this side. So if we drew a line directly down our histogram, okay, and remember this was our histogram, and then basically what they did is they just figured out what was the shape of that data. Okay, I don't know if you can see it underneath, but you can lightly see the histogram underneath there. That's what we're doing, okay? And so our histogram is under there. And so basically it's saying if we were to take this histogram and cut it right down the middle and fold it in half, then this side of data, the bars that are sitting here, so remember these represent the bars that are on the histogram, so we look like this, okay? So we have all of these intervals that are looking like this, right? And so these little bars that are represented right here would represent the data that's represented on the histogram, okay? And so that's what the shape is called when we look at the shape of the histogram. Symmetrical means this shape shows that the data is to be evenly dispersed on both sides of the center of data. So you're going to find your exact center of your data, and then you're going to look at it and it's evenly dispersed. So this shape goes exactly the same on both sides, okay? Then that's symmetrical, all right? The different one is called skewed. And what skewed is we have, it leans to one side or the other. And so skewed is called skewed shape. This shape shows the data to be uneven or dispersed to one side or the other. So if you look at this shape of your histogram, so again, if I was to put this histogram under there, then we would say that the highest point of the data on this one would be more towards the end of your graph, whereas the highest point of this graph it would be closer to the smaller end of your data collected. And so what we're saying by looking at these two graphs is that our highest point of data, because remember this is the y-axis and it's telling you the numbers of something, so our highest point of data happens to fall in our data that's further away from 0. Because remember, on all graphs, right here where the x and y collide, that's 0. Okay, so where the x and y collide, that's 0. So according to this graph right here, it means our data, its highest point of data was really far away from 0. Whereas on this one, our highest point of data is very close to 0. So do you see that? So the skew shape, this shape shows the data to be uneven and dispersed to one side or the other. And so what we have to do to explain this is skewed left means the data is skewed towards the smaller values. Okay, skewed left. Skewed left. Left is over here, but look, it's low on the left and high on the right. So it's called skewed left. So that means move away from the left and get bigger. Skewed left means the data is skewed towards the smaller values. Skewed right means that the data is skewed towards the larger values. So that means that closer to 0, immediately larger. Okay, closer to 0, you're staying smaller. So that's how you get the smaller values to begin with, because your high point is further away from 0. That means you're getting bigger. Whereas skewed right means the data is skewed towards the larger values. So immediately when you start, your values are really large. Immediately when you start over here, your values are small. Immediately when you start, your values are very large. So that's how you have to determine what skewed left or what skewed right means in your data. Okay, holy moly, we covered a ton of information. Let's do a quick review. So our goal in statistics is we have to be able to decide numerical or, statistical or non-statistical, first of all. So a question, a survey question, is it statistical or non-statistical? Typically, if it's a survey question, it's going to be statistical. So you have to decide, is this question collecting data or not? Then, once you figure out that it is, you have to decide, is it numerical or is it categorical? Numerical or categorical, right? And we did a little practice with that. Then, after you figured out if it was numerical or categorical, then we had to figure out a way to organize it. So looking at the organization of it, we have the dot plot, which is kind of fun, the frequency table, which is still fun, and we have our histogram, which is still fun. Each one of these different types of graphs gives you more and more information as you go. Then, once you get to your histogram, you have to remember the intervals have to be evenly spaced, the bars have to be touching, and then the data is shown on there. Then, once you have your data on a histogram, then you have to understand the shape of the histogram. They are either symmetrical, which means that the data is equally dispersed on both sides the same way, or skewed, and skewed left means that your data is focused on the smaller values. Skewed right means that your data is focused on the larger values. Okay, holy moly, that was a lot of information. Okay, so going back to understanding distributions. Today we will learn how to identify different types of data and how to use them. We totally did that. Lots of information. Question, what are the two types of data? The two types of data that we have are numerical and categorical. Okay? All right, guys, I know this was a ton of information, a long video. I apologize, but we've got to make sure that we have this understanding before we can go any further with statistics. I'll see you all later. Bye!